back to your favorite intermediate algebra course. We're going to talk today about recursive rules for sequences. So we've been dealing with explicit rules for sequences and series this whole time. Now we're going to talk about some recursive rules. So here's a good example here to start off. What do I mean about a recursive rule? And a recursive rule just means that it's a rule for a sequence. It gives the beginning term or terms, and then it depends on. So then a recursive equation that tells how the a subscript n is related to one of the preceding terms. Okay, so here's this example here in green. All right, so let's write this out. Our first term is 2, and then we got 1. So here's our first term, here's our second term, right? And we're trying to figure out, if we wanted to, or I should say we are trying to figure out the first 5 terms here. So we need A3, we need A4, we need the 5th term, A5, and so on, right? Okay, so I go ahead and I write my recursive rule. Now we want the third term, right? So n is 3. So I got 3 minus 2 minus. So I got A3 minus 2 is 1. So it's the first term minus the second term. So I say, oh, well, what's the first term? 2. All right, there's our first term. Minus our second term. What's our second term? 1. So our third term is 1. So it goes 1 right there. Third term. Okay. Now let's do the fourth term. According to this recursive rule, the fourth term is the second term minus the third term. Well, our second term is 1. Our third term is 1. So it looks like our fourth term ends up being 0, right? So our fifth term is going to end up being what? You can probably see the pattern here. The fifth term is going to end up being the third term minus the fourth term, right? Once I plug it in. So our fifth term, our third term was 1. Our fourth term was 0. So it looks like our fifth term ends up being 1. Oops, 1. There we go. And there's our first 5 terms. Okay, so you just plug it into the formula and then substitute in for the terms that you need, and that's a recursive rule. So it's dependent on previous terms. Okay, let's do another one here. Write the first 5 terms of this recursive sequence. So we already got the first one, it's -1. We got the second one, it's 2. Trying to figure out the third, the fourth, and the fifth. Okay, here's our rule. an minus 2 times an minus 1. So this is just saying my nth term, so like if it's my third term, right, is 2 terms previous times the term right before it. Okay, so you can see that here. See how that's A1, so 2 terms previous. A3 minus 1, that's the second term. So the first term, what is the first term? Well, that's that -1 they gave us. They gave us the second term, that's 2. So it looks like -2 ends up being our third term. -2. Okay, let's do the next one. So the fourth term, according to the rule, would be the second term times the third term, right? Well, the second term is 2, third term is -2. We just found that third term, so -4. So the fourth term is -4. And of course, what would the fifth term be? The fifth term would be the third times the fourth. So -2 times -4 is 8, ... right? So there's our first 5 terms, okay, for that recursive rule. Now let's go ahead and write some recursive rules for arithmetic sequences, okay? So it gives us the first term, A1, and then this time it says the common difference is 7. So A1 is 7, first term is 7, and our common difference is, A1 is 7, and our common difference in this case is, oh, you know what, I wrote this wrong. I'm gonna have our first A1 be 1. Sorry about that. Let me do that. So our A1 is 1 and our common difference is 7, okay? Right, first of all, the explicit rule So if you remember the explicit rule, we did this a couple sections ago. Okay, there's our explicit rule. So we can find our first term is 1, our n, leave it as n, and our common difference is 7. So if you remember, we distributed that common difference, combined like terms. There's our nth term explicit rule. Explicit meaning I can jump to any term that I want. It's really a more powerful rule, if you will. You know, if you want to jump just to the 10th term immediately, I just plug a 10 in, right? And I'd have 70 minus 6. So 64, that's my 10th term, and so on, right? So that explicit rules, that's a good rule. All right? So we wrote the explicit rule. Now we want the recursive rule. So if you think about this, you know, our first term is 1, and there's a common difference. Common difference is 7. That means it goes up 7, right? It's arithmetic. So the next one's going to be 8. And then it goes up 7 again. So the next one's going to be 15. And up 7 again, 22, then 29, and so on, right? So it goes up 7 each time. So you have, you know, a recursive rule for if it's an arithmetic sequence. For an arithmetic sequence, you're going to have the nth term is the previous term. And what did we do to that previous term? So the previous term, a subscript n minus 1, and we added 7 each time, didn't we? We added d each time. So that's the general rule. If it's an arithmetic sequence, there's the general rule for that. So a, n minus 1, and then we just add in our 7. There's our recursive rule right there. Okay, so for this arithmetic sequence, right, the indicated rule again, where your first term is 9 and your common difference d is 5. So the explicit rule, use the old explicit rule, plug in our first term, plug in our common difference, combine like terms there, and there's our arithmetic, there's our explicit rule for that arithmetic sequence. Now let's do the recursive rule. So if you remember again, the first term, 9, common difference is, sorry, let me write this on here. Common difference is 5, so we go up 5 each time, don't we? And then up 5 again, since this is arithmetic, up 5, and so on, right? The general rule for an arithmetic sequence, that's the general recursive rule for an arithmetic sequence for the nth term is you take the previous term and you just add in your common difference. In this case, it's 5, right? Now, if your common difference was a negative 5, of course, that'd be a n minus 1 plus a negative 5, or a n minus 1 minus 5, right? So the sign is important there on your common difference. Okay. All right, what about for a geometric sequence? Probably could have predicted we're going to jump to that here. So for a geometric sequence, you have, grab my thing here, you have your explicit rule, a1 r to the n minus 1, and they give you the first term, they give you the r, there's your explicit rule, right? Now think about it. Let's think about this geometric sequence. Let me write this out again. 6, and your now your common ratio is 2, right? So we're multiplying by 2 each time. So 6 times 2, 12. 12 times 2, 24. 24 times 2, 48. 96. Anyways, right? So we're multiplying by 2. So if you think about your general recursive rule for a geometric sequence, is you're going to take your previous term and you're just going to multiply it by r. So I like to write it. You can do it either way. Some textbooks will write it this way: r times the previous term, right? So in this case, we'll have the 2 being our r times the previous term, a n minus 1. Okay, so if you think about it, let's say you're finding your, I don't know, you're finding your second term, right? Second term is 2 times a to the 2 minus 1. 2 times the first term. Well, the first term was 6. So 12, it was your second term, right? Which we already knew that. But anyways, that's our recursive rule for that geometric sequence. Let's try another one like that. Let's go back to the explicit rule here. AN is A1 R to the N minus 1. So we got 8 as our first term. And then we got R, a half to the N minus 1. There's our explicit rule. Our recursive rule is R times A to the N minus 1. So it's R times the previous term. And our R is a half. And leave it right there with our previous term. Okay, so half times A to the N minus 1. Now sometimes they're not always going to be arithmetic or geometric. Like this one, you just got this general sequence here. It's got a pattern to it, so you kind of got to think about this pattern. So you're looking at that first term, like, wow, gosh, it looks like, let me write the terms here below. My first term is 20, my second term is 15, my third term is 5, fourth term is 10, fifth term negative 5. Is it arithmetic? Well, you're looking at it and you're like, well, it looks like it goes down 5. Does it go down 5 again? It goes down 10 and then it goes up 5. Wait a minute, that's not arithmetic, is it? Well, that was a geometric. Is 15 divided by 20, does it multiply by the same thing? Here, what's our R? It's 15 over 20. Is that the same thing as the third over the second? And so on, that's 3/4. This is a third. Oh, wait a minute. Nope, no common ratio here. You're multiplying by 3/4 initially, then you're multiplying by 1/3, and then you're multiplying by 2, and so, okay, so it's definitely not arithmetic. It's not geometric. What pattern do you see to this thing? You look a little closer, you're like, wow, gosh, it looks like 20 minus 15 gives us 5, right? And 15 minus 5 gives you 10. 5 minus 10 is negative 5. And if we continue on, hold on, let me stop here, I guess. Got that little interruption there, I had a student come in. So, yeah, so we're looking at this, and you kind of start noticing, your third term looks like it's the first term minus the second term, right? Isn't that the first term is 20 minus 15. Hey, look at that, it's 5, right? Your fourth term looks to be your second term minus your third term. 15 minus 5 is 10, right? And so on. Your fifth term looks like your third term minus your fourth term. So you got your 5 minus 10, oops, minus negative 5, okay? And now you can write it. Try and write this. Try and write that in your general format. So you say, well, my AN would be 2 terms previous. You got your third term. 2 terms previous was your first term. 2 terms previous minus the one right before it. So AN minus 1. Okay, that's your rule. But you also have to give them, along with this recursive rule, you got to give them 2 terms. So you got to give them the first term and the second term to get them started. Okay, because it's dependent on 2 previous terms. Okay, so there's your recursive rule for that sequence. You guys make sure you bring your questions to class. See you soon.